In this lesson, we'll continue our discussion on learning target number 2, focusing on Gay-Lussac's law, which describes the relationship between the pressure and temperature of a gas. Why do you need to keep aerosol cans away from heat sources? Because in a rigid container, as the gas heats up and the volume is not allowed to change, the pressure builds and builds inside the can until it explodes. This is formally described by Gay-Lussac's law. The pressure of a fixed amount of gas at constant volume is directly proportional to its Kelvin temperature. Because this is a direct relationship, P varies with T. Now both terms are in the numerator of the proportionality statement because if temperature goes up, pressure goes up, or if temperature goes down, pressure goes down. In order to change this into a math equation, we need to introduce a constant. And because this is the third gas law, the Gay-Lussac's constant is known as K3. But just like with Boyle's law and Charles's law, we're going to set up an experiment so that we can get rid of the constant K3, because we don't want to have to look up the gas constant for every single question that we do. If I take an aerosol can and have some sort of initial temperature and pressure, we can record that as P1 equals K3 times T1. If I have a final temperature, let's say, for example, I stick the aerosol can out in the sun, then I'll have P2 equals K3 times T2. I can rearrange these equations so they say K3 equals. K3 is going to equal P1 over T1. And for final conditions, K3 is going to be equal to P2 over T2. Again, because K3 is a constant, it doesn't change as long as you don't switch out the type of gas you're using. I can make these two equations equal to each other, and P1 over T1 can be set equal to P2 over T2. This is the form of Gay-Lussac's law that we're going to use. However, the following conditions must be met in order for Gay-Lussac's law to be true. Temperature must be inputted into this equation in kelvins. The volume of the gas must be held constant. Also, the amount of gas is constant. And finally, Gay-Lussac's law can only really be applied if your gas is in a rigid container. Another real-life application of Gay-Lussac's law is that it explains why when you apply hairspray or body spray, it always feels cold. When you open the canister and the spray comes out, it goes from a high pressure to a low pressure, causing the gas to cool. Let's try out some math questions using Gay-Lussac's law. On a warm winter day, so -5 degrees, you check your car's tire pressure and find it to be 2.18 atm. That's my initial conditions. -5 degrees converted into Kelvin is 268. I want to know what the final pressure of the tires are when a cold snap hits and the temperature drops to -30 degrees Celsius. That's 243 Kelvin. In order to rearrange for P2, I need to times both sides of my equation by 243. Now looking at my sig digs, I have 3 in each of the values that I subbed into my equation. My final answer is 1.98 ATM. Try out example 2 on your own. Pause the video until you have your answer. Here's the answer for example 2. The initial conditions of the tank are 178.9 psi at 55 degrees Celsius. That's 328 Kelvin. For the final conditions, it asks me what is the temperature when the tank explodes, and the tank will explode at 13,000 torr. Before I can sub in the pressure, I need to convert it into psi. P1 and P2 have to be in the same units. Now it doesn't matter what you convert into. You could convert both the pressures into psi's or both into torr. I'm going to go into psi. So I'm going to times by psi and divide by 4. So I have to multiply by 14.7 and divide by 760. To get T2 by itself, there's a couple of different math ways that you can do it. I like cross multiplying. Then to get T2 by itself, I divide both sides by 178.9. I want to convert this into Celsius, so I'm going to subtract this by 273. And then looking at my numbers, I have 3 sig digs here, so I can only have 3 sig digs in my final answer. So I round down to 188 degrees Celsius. Complete the Gay-Lussac questions listed on your Unit 5 assignment cover sheet.